Our Gateway Physics Revision P1. Morse code. The Morse code uses a series of dots and dashes to represent letters of the alphabet. This code is used by signalling lamps as a series of short and long flashes of light. It is an example of digital signal. Sending signals. Sending signals. When a signal is sent by light, electricity, microwaves or radio, it is almost instantaneous. Each method of transmission has advantages and disadvantages. Can the signal be seen by others? Question mark. Question mark. Can wires be cut? Question mark. And how far does the signal have to travel? Question mark. So those are the advantages and disadvantages. Next is laser light. Laser light. White light is made up of different colours of different frequencies out of phase. Laser light has only one single frequency, is in phase and shows low divergence. Phase, phase and the surface of a CD is pitted. The pits represent the digital signal. Laser light is shone onto the CD surface, and the difference in the reflection provides the information for the digital signal. New section. Critical angle. Now in the textbook it actually shows diagrams for this, so what I'm going to do is read this part and then I'll put a picture of the diagrams on as well. So When light travels from one material to another, it is normally reflected. When light travels from one material to another, it is normally refracted. Refracted. If it is passing from a more dense material to a less dense material, the angle of reflection is larger than the angle of incidence. I don't want that, I've just said it wrong. If it is passing from a more dense material to a less dense material, the angle of refraction is larger than the angle of incidence. When the angle of incidence, refraction is 90 degrees, the angle of incidence is called the critical angle. The angle of incidence is called the critical angle. If the angle of incidence is bigger than the critical angle, the light is reflected. This is total internal reflection. Telephone conversations and computer data are transmitted long distances along optical fibres at the speed of light, which is, open brackets, 200,000, 000 kilometres a second in glass, close bracket. Some fibres are coated to improve reflection. Some fibres are coated to improve reflection. Right. Next part, endoscopy. Endoscopy, I can't say it. Endoscopy. Right. The scope allows doctors to see inside the body without the need for surgery. The light passes along one set of optical fibres to illuminate inside of the body. The light is reflected. The reflection light passes up another set of fibres to an eyepiece or camera. The reflected light passes up Another set of fibres to an eyepiece or camera. Full stop. Reading part 4 benefited you as much as it benefited me.